Hi you guys, welcome to the video where we're going to be going over the third 9 weeks test review. Let's start off with question number 1. I'm going to rewrite the problem. So we have 3 times the cube root of 2x minus 1 minus 6 equals 3. When you're solving, make sure that you do PEMDAS backwards. So it's helpful to write PEMDAS on your paper and then work your way backwards. So first we need to add or subtract. I do see that there is a minus 6. The inverse operation would be to add 6 on both sides. That cancels out and we're left with 3 times the cube root of 2x minus 1 is equal to 9. There's nothing else to add or subtract for now, so I'm going to cross that out and move on to multiplication and division. There's a 3 in the front that can be divided out on both sides, so I'm going to divide both sides by 3. These 3's cancel, leaving us with the cube root of 2x minus 1 is equal to 3. Now, we're done with the multiplication and division. Now we can work on the exponent. We have a cube root, and if you remember from inverses, the inverse of a cube root is a cubic function. So I can take all of this and raise it to the power of 3 because I know that a cube root and a cube are going to cancel out. So now we have 2x minus 1 is equal to 27. From here, it's basic algebra. We're going to add 1. These cancel out, leaving us with 2x is equal to 28. We can divide both sides by 2. These 2's cancel out, and you have the answer x is equal to 14. Now, the instructions do say check for extraneous solutions, so make sure you plug it back in. So now we're going to do our check. So we're going to do 3 times the cube root of 2 times 14 minus 1 minus 6 equals 3. Okay, you're going to go and plug this into the calculator. We're going to write 3 times the cube root of 2 times 14 minus 1. Outside of the root, we're going to write minus 6 and then equals 3. The answer is true, so I'm going to write true here, and that means the answer would be positive 14, which we write in curly brackets. Okay, let's do another one. We have 2 times the cube root of 3x plus 1 plus 11 equals 1. So remember, we're doing reverse PEMDAS, so we're going to subtract 11 on both sides, leaving us with 2 times the cube root of 3x plus 1 is equal to negative 10. Next, we're going to divide by 2. These 2's cancel out, leaving you with the cube root of 3x plus 1 is equal to negative 5. Just like before, to get rid of a cube root, you're going to cube both sides. So we're going to cube this, which cancels out, leaving us with 3x plus 1 is equal to, now if you don't know negative 5 cubed, you can put it in the calculator, but make sure you use your parentheses. So parentheses, negative 5 cubed is negative 125. From here, we're going to subtract 1, which gives us 3x is equal to negative 126. You can divide by 3 to get x by itself. And again, if you don't know what that is, you can put it in the calculator. It's the wrong calculator. All right, negative 126 divided by 3 is negative 42. But before you box it in, make sure that you check. So we're going to plug it in now. We're going to type in 2 times the cube root of 3 times negative 42 plus 1 plus 11 is equal to 1. 2 times the cube root of 3 times negative 42 plus 1 plus 11 equals 1. Okay, and we get that that is true. So the answer would be negative 42. Moving on, we have a word problem. The shoulder height in centimeters of an African bush elephant is modeled by the function h of t equals 64.75 times the cube root of t plus 81.2, where t is the age in years of the elephant. If the shoulder height of an elephant is 300 centimeters, what is the approximate age of the elephant to the nearest year? Type only the number. Hint, substitute 300 for h of t, not just h. So the important thing with word problems is always figuring out what the variables are. So they tell us that t is age in years, and then the shoulder height would be h of t. Okay, let me put that in another color. Shoulder height is h of t, and they said if the shoulder height is 300 centimeters, so we're going to replace h of t with 300. So it'll be 300 equals 64.75 times the cube root of t plus 81.2. Okay, we're still doing reverse PEMDAS because we're trying to solve for a variable. So first, what can you add or subtract? That would be this 81.2 on both sides. Those cancel out. We can go over to our calculator. 300 minus 81.2 would be 218.8 times all of this. Okay, after that, we're going to divide the 64.75, because at this point you're trying to isolate the variable. So now we can put that in the calculator. Divide by 64.75. You get 3.379 is equal to the cube root of t. Okay, remember to cancel out a cube root, you cube it because they're inverses of each other, and what you do to one side, you do to the other. So these cancel out, and now you can go to the calculator and cube this. Now I'm going to copy and paste it because you don't want to round in the middle of the problem. So I'm going to take all of this and raise it to the power of 3, and we get 38.585. I'm going to say approximately 38.585. But if I keep reading in the question, it does say, what is the approximate age to the nearest year? So I'm going to round this even more and just say about 39 years old. Okay, moving on. If f of x equals 2x plus 4, which graph represents the inverse of f of x? So remember, to find the inverse, all you do is swap out x and y. I'm first going to replace f of x with y because we know that those are two ways of writing the same thing. From here, I'm going to switch x and y, so it'll be x equals 2y plus 4, and the goal is to get y by itself. So again, we're doing reverse PEMDAS. I'm going to subtract 4 on both sides to get x minus 4 equals 2y. To get y by itself, I have to divide by 2. So I'm going to divide everything by 2. These cancel out. Okay, now this x had an imaginary 1 in front of it. Now I can pull this out and do 1/2 x minus 2 is equal to y. The last step is to swap y for the correct inverse function notation. And then we can try to find the correct graph. From algebra, we should know the slope-intercept form. So I know that the slope will be 1/2 and the y-intercept is -2. So I'm going to look at this graph. Here's the -2, -2, -2, -2. So the only graph that even has that point would be answer choice C. Okay, let's go on to the next one. Here we're given a graph and it says graph the inverse. Okay, in the previous problem we solved it by hand. by swapping x and y. We can also do that on this graph by finding some points and then switching the x and y values. So for example, here we have negative 4, 5, we have 0, 3, and we have 4, 1. So all we need to do is swap these points around. So this would become 1, 4, this would become 3, 0, and this one would be 5, negative 4 on the inverse graph. So what I can do is try to find these on here. So let's look first for 5, negative 4. 5, negative 4, there's nothing here, so A is eliminated. 5, negative 4, okay, B is a contender. 5, negative 4, C is eliminated. 5, negative 4, D is eliminated. So B would be the only logical answer based on you just switching your x and y values. Okay, and number 6, we're going to find the inverse of f of x equals negative 4x minus 12. We're going to start by replacing f of x for y and then switching your x and y values. We're going to do reverse PEMDAS, so we're going to add 12 on both sides to get x plus 12 is equal to negative 4y. We're going to divide every single term by negative 4 so we can isolate y, and these negative 4's cancel out. Remember that there's an imaginary coefficient of 1, so this would become negative 1/4 x minus 3 is equal to y. And the very last step is to switch y for the inverse of f of x notation. And then we just try to find the answer. A is incorrect, C is not negative, D is incorrect, and the only one that matches would be answer choice B. Okay. Here's another one, find the inverse. We're going to change f of x to y. And then we're going to switch our x and y values. So we're going to have x equals 2y plus 3 divided by 4. Anytime you want to get rid of a denominator or a fraction, you multiply the denominator on both sides. So these cancel out, leaving us with 4x equals 2y plus 3. We're trying to get y by itself, so I'm going to subtract 3 because we're doing reverse PEMDAS. So now we have 4x minus 3 is equal to 2y. To get y by itself, I need to divide everything by 2 so that these 2's cancel out. And I can rewrite this as 2x minus 3 over 2 is equal to y. Don't forget the last step is always to switch y to the inverse of f of x notation. So we have positive 2x minus 3 over 2. So I'm going to eliminate these that have negative 2x. And then the correct answer choice would be D as in dog. Okay, here's another one. What is the restricted domain of f of x equals x plus 4 squared plus 8 such that the inverse of f of x is a function? So first, let's go and find the inverse. So remember, we're going to change f of x to y so that when we switch, we're going to write x equals y plus 4 squared plus 8. We're trying to isolate y. We're doing reverse PEMDAS. I'm going to start with subtraction. That gives us x minus 8 equals y plus 4 squared. To get rid of the square, you're going to take the square root on both sides so that the square and the square root cancel. So every time you do the square root, do not forget the plus or minus symbol. So plus or minus the square root of x minus 8 is equal to y plus 4. The last step to get y is going to be to subtract 4. So we have plus or minus the square root of x minus 8 minus 4 equals y. The last step is to switch y to the inverse of f of x notation. So we have plus or minus the square root of x minus 8 minus 4. Okay, so looking at the answer choices, they gave us some equations here that the inverse of f of x equation would be. Off the bat, we can eliminate A and C because it's not what we got. Now let's analyze b and d closer. It says if the domain of f of x is restricted to -4 to infinity, then the inverse would be the negative square root. D says the domain is restricted to -infinity to -4, then the inverse would be the negative square root. So remember that the square root function, you have a positive and a negative side, which determines the domain determines if you use the positive or the negative side. So what you do here is if you go to positive infinity, then you have a positive square root. And if you go to negative infinity, then you have the negative square root. Okay? Because this one had a negative infinity, it does not match the domain. So B would be eliminated and D would have to be the correct choice. So if you're given these types of problems, just remember if you go to positive infinity for the quadratic, then you have the positive square root as the inverse. But if your parabola goes to negative infinity, that means you're only doing the left side, then you have the negative square root as the inverse. Okay? Let's try that again. They gave us a quadratic function, x plus 2 squared. Which of the following could be true about the inverse? I'm going to change f of x to be y, and then we're going to change x and y. So it'll be x equals y plus 2 squared. I need to get rid of the square by taking the square root so that the square and the square cancel. And remember that every time you take the square root, you do plus or minus the square root of x equals y plus 2, and the last step will be to subtract 2. The last step is to change y for the inverse of f of x notation. So we have plus or minus the square root of x, and then on the outside we have a minus 2. Now notice that in the answer choices here, they tried to trick you because they're hoping that you forget that that minus 2 is on the outside. So we can eliminate C and D. Now let's analyze A and B. So they both go to positive infinity. So these are associated with the positive square root. Okay. Now this one has no sign, so there's an imaginary plus, and this one does have a negative. So A does not match, but B does. So B is the correct answer. Okay. Let's go on to number 10. If the domain of f of x is equal to -1/4 x minus 3 squared plus 5 is restricted to -infinity to 3, which graph represents the inverse of f of x? Okay, so on this one, I see that we are restricted to -infinity. That means that this parabola will only be the left side. And remember that the left parabola, when you talk about the inverse, only corresponds to the negative square root. You are not going to have a positive square root, okay? Now, the inverse of any quadratic is a square root. So I can eliminate all these answer choices that look like parabolas, which would be D. Okay, D is a parabola, that one is out. I can also eliminate B because this would be the positive square root and the negative square root, and I need only one of them, so this one would also be eliminated. Okay, now if you want to pick between A and C, just remember that the negative square root is below, the positive square root is above, so the answer would be C. And you could always do this by hand if you wanted to. I can do it for you if you want. So we're going to change f of x to be y and then switch your variables around. And we're going to do reverse PEMDAS. So I can do -5 to get x minus 5 is equal to -1/4 times y minus 3 squared. To get rid of that -1/4, you could divide by -1/4, but I would recommend to multiply by the reciprocal, which is -4 on both sides. Now this -4 does have to be distributed over here. So we're going to get -4x plus 20. And on this side, the -4 and the -1/4 cancel, leaving you with y minus 3 squared, at which point you would take the square root to cancel out the square. So now we have plus or minus the square root of -4x plus 20 equals y minus 3, and the last step would be to add 3. And the last step is to change y to the inverse of f of x notation. And also we're going to not put plus or minus because earlier we talked about the domain restriction. Because we're dealing with a left parabola that goes to negative infinity, we are only going to include the negative square root as our final answer. So it'll be the negative square root of negative 4x plus 20 plus 3. Okay, so we can go ahead and graph that. So I'm going to open a new graph and we're going to type in negative square root of negative 4x plus 20 plus 3. And you can see that it matches the answer choice that we had already selected, which is answer choice C, but that's in case you want to do it by hand. Okay. Let's go on to question 11. If the domain of f of x is equal to x minus 1 squared is restricted to negative infinity to 1, what are the domain and range of the inverse of f of x? So remember that the domain and range switch. So if you have the original function, the domain of the original becomes the range of the inverse, and the range of the original becomes the domain of the inverse. So if we have the domain of f of x is restricted to negative infinity to 1, what do you think that means? That means the range of the inverse is negative infinity to 1. So let's see if we can eliminate. This range is wrong, this range is wrong, this range is wrong. So only C would have the correct answer. Now, if there were, more answer choices that were contenders, then you would be forced to do it by hand. So I'll show you how to do it by hand. So we'll have y equals x minus 1 squared. To get rid of, well, first we got to switch x and y. And then to get rid of the square, we'll take the square root to cancel that out. So now we have plus or minus the square root of x is equal to y minus 1. We can add 1. And then the last step would be the inverse of f of x. Now, to determine whether you're going to do plus or minus, remember you pay attention to this. This was the left parabola, which means you'll have the negative square root. So we'll do the negative square root of x plus 1. And then you can use the calculator to graph it and figure out what it's going to look like. So let's graph negative square root of x plus 1. Okay, and then we can verify that C is the correct answer. You can see that the smallest x value is 0, and then it goes all the way to the right, which is positive infinity. And then the range starts at the bottom to negative infinity, and then it stops, the highest y value is positive 1. Okay, so let's go on to question number 12. Referring to f of x is equal to 1 over x, how does g of x equals negative 3 over x minus 5 translate? Select all the correct transformations. So just as a refresher, for your transformations, you have 1 over x minus h plus k, where this h is your left and right, the k is your up and down, and then sometimes you're going to have negatives here. So if you have a negative here, that'll be a reflection over the x-axis. And then sometimes you're going to have an a value. Okay, so the A could be, like here we have 1 in front of this parentheses, and then we have a 1 in the numerator. So this would be your value for A, and those numbers can change. So for example, if this was 3, then it would be a vertical stretch. If this was 1 over 3, then A would be 1/3. That would be a vertical compression. Okay, so let's see what we have here. We have a reflection over the x-axis because the negative is outside of the house. Remember, the house is considered the denominator. So in the denominator, all we have right now is a positive x. So that negative is outside, so that'll be a reflection over the x-axis and not over the y-axis. Okay. Next, I see a 3, and there's an imaginary 1 in front of this x. So this 3 over 1 is basically telling you that A is 3, which is a vertical stretch. So if A is larger than 1, it's a stretch. If A is smaller than 1, it's a compression. And for these graphs, if you remember, we are not doing horizontal stretches or compressions. So we're just doing vertical stretches and compression. So you grab the coefficients that are in the front and then determine is it larger or smaller than 1, determining if it's a stretch or a compression. And then the last thing we have is this -5, which would be 5 units down. And since there was nothing in the house, then there is no left or right translation, so D is incorrect. So the 3 correct answers are A, C, and E. Okay, let's try this one. If f of x is 1 over x, how does g of x equals 2 times f of x minus 2 plus 2 translate? Okay, so this 2 is being multiplied outside of the house, and it is greater than 1. So if a is greater than 1, that is a vertical stretch of 2, so the answer would be A. We're going to eliminate B. Next, we have a -2 inside of the house. This is your H value. Remember, everything inside the house is a lie. So if it says -2, we're actually going to the right 2. So this is incorrect. We're not going left. We're going to the right 2. So remember, you always switch the values. So H is +2, going to the right. The last thing we have is +2. This is your K. And this one is the truth. So we're going up 2 units. So the only 2 answers are A and D. Okay, next we have if the graph of f of x is equal to 1 over x is changed to g of x equals -1/3 times f of x plus 2, which is the graph of g of x. Okay, so what you could do is identify the transformations. So we have a negative on the outside, which means that we're reflecting across the x-axis. This 1/3 indicates A is 1/3, so that is a vertical compression because it's smaller than 1. And then we have this +2 on the outside, which would be a vertical shift up 2 units. Okay. Now, if you remember on the rational function, you have normally a VA at x equals 0 and an HA at y equals 0. Okay. But because we're moving up 2, that means that our horizontal asymptote has to be shifted up 2 units. So let's see if they all have a horizontal asymptote at 2. A does, C does, B does, and so does D. Okay. Another thing, so that didn't help us. Another thing we can do, and they all have a vertical asymptote at x equals 0 also. The parent function for a rational function looks like this. So the way I remember that is that the parent function is always going to have 1/2 of the graph in quadrant 1, and it always goes up. Okay, that's for a positive. So you see how this one, it's in quadrant 1 and it goes up. This is in quadrant 1 and it goes up. I know that I can eliminate A and C without having to graph. Because this is reflected over the x-axis, I can expect to see the opposite here, having quadrant 1 completely blank. Okay, so that would indicate the reflection. It was shifted up 2 units, and then a vertical compression would bring the graph closer. So the correct answer would be D as in dog. But again, you have the calculator, so you can just graph it. So what we can do is we can graph the original, which is 1 divided by x. Okay, and then we can graph tab. We have negative 1/3. Now remember, when you're going to type f of x, you have to remember what number you used for the previous one. So my previous one, I used 1. So I'm going to type in f of 1, and notice that it gets in bold, f of 1 parentheses x close parentheses plus 2. Okay, and then you press enter, and then you can analyze. Hold on, like you cannot see what I'm seeing. Okay, so here is the graph, and you can see that it's tighter together. You could also pull up the table if you still are not feeling too confident about selecting the answer that you're picking. So let's say you do Control T, or you can go to settings and then go to table. Just remember that you need to go to the red one. Well, for me it's red. It might be a different color for you. But for example, let's say 1 and 1.6. So here would be 1 and then 1.6. So it's pretty close to the 2, so that one makes sense. As opposed to this one that is 1 and then 1.6 is here, and you can see that the graph is nowhere to be found. So that's another way that you can verify your answer. So you can just graph them. And then pull up the table to make sure, because B and D look similar if you're not paying too much attention. Okay, so let's try question number 15. If the graph of f of x is equal to the cube root of x plus 3 minus 3 is changed to g of x equals f of x plus 1 plus 2, which is the graph of g of x? Well, all you have to do is take this and put that over here. So basically they're telling you to replace x with x plus 1. So I'm going to change all of this here. So f times x plus 1 is equal to the cube root of x plus 1 plus 3. And then outside we still have a minus 3. So I'm replacing the value of x with x plus 1 because that's what the question asks for. Okay, so everywhere there was an x, I swapped it out with x plus 1 because they told me to plug in x plus 1. Now I'm going to simplify this. So f of x plus 1 is equal to the cube root of x plus 4 minus 3. Okay, now all of this, I'm going to go plug it in here because we just simplified it. So g of x would be the cube root of x plus 4 minus 3 plus 2. Okay, so that's all of this here. So this was the f of x plus 1 that I just put here, and then do not forget the 2. From here we can simplify, so it would be the cube root of x plus 4, and then negative 3 plus 2 is minus 1. So we're looking at transformations. Remember, h is the opposite, so instead of plus 4, we're going back 4, so it'll be left 4. And then this one is the truth, so this one goes down 1. So I should expect to see the vertex at negative 4, negative 1. So let's go see negative 4, negative 1. This one doesn't even have a point there, so I'm going to eliminate A. B, negative 4, negative 1. There's nothing there. C, negative 4, negative 1. That one looks like a good contender. And then this one, negative 4. Even though this one has a point, you guys, the vertex of a cubic is over here. Okay, so this is the vertex. And even though it has the point -4, -1, it is not the vertex. So the answer would be C as in cat. Okay, you could also use the calculator using the same strategy that I told you earlier. So we can do the cube root of x plus 3 minus 3, press enter, and then you can type in f, and then I used 1, so I'm going to use f1 of x plus 1 plus 2, and then you can see that it matches the one that we had selected over here. Okay, so that's just an extra strategy. Let's move on to question number 16. Which values for x make this equation true? So I see we have two rational equations that are being subtracted, and then they're set equal to another one. So we're going to be combining a few of the last few lessons, so lesson 34 and 35. So remember that when you are solving these, I like to start off by putting everything in parentheses, and then I want to figure out, how do I get a common denominator? Sometimes you're going to need to factor first. To factor this one, the greatest common factor is x, and whatever you divide by is what you put on the front, and then you subtract the exponent. So x squared minus x to the power of 1 is 1x, and then these x's cancel, leaving you with minus 4. So I see that the denominator is x minus 4. This one only has an x, so I need to add an x minus 4 to it. And then the last fraction has x minus 4, but it's missing the x, so I'm going to add x to this one. Once all of the denominators are the same and they all have the same two factors of x times x minus 4, I can go ahead and focus on the numerators. So I'm going to do 32 minus 1 times x minus 4 equals 3 times x. From here, we can distribute the -1 into here and distribute the 3 here, giving us 32 minus x plus 4 is equal to 3x. I want to combine my like terms, which are 32 plus 4, which equals 36. And then to solve for x, you want to move everything to the same side, so I'm going to add x. 36 is now equal to 4x. Divide by 4 to isolate x, and you get that x equals 9. Okay, before you box that in, these are rational functions which could have vertical asymptotes that make the whole function undefined. So you always want to check your vertical asymptotes, which, if you remember, they come from setting the denominator equal to 0. They all had the same exact denominator, so you don't have to do this 3 separate times. You just have to get the common denominator of x times x minus 4 and set it equal to 0. And now you can separate this into two cases to solve. So x equals 0, and for this side, we're going to add 4. So x equals 4. And these vertical asymptotes let you know that x cannot equal 0 and x cannot equal 4. But our solution of 9 is okay, so I'm going to put it in curly brackets and box it in. Okay? Now, the number of x's that you see in your vertical asymptote in your denominator is exactly how many asymptotes you should have. Okay, so if I see 2 x's here, I should have 2 vertical asymptotes. If this was, let's say, a number, then this would be irrelevant, and there should only be 1 vertical asymptote for the only x that we have there. Okay, so be sure that at the end you have the same amount of vertical asymptotes as you do x's in your factored form. Okay, number 17, we need to add these two and then set it equal to this one. All of these have different denominators, so I'm going to have to factor all of them using the x method. So I'm going to start off with trying to figure out what two numbers multiply to 24 and add to 11. And I know those numbers are 8 and 3. So I'm going to put this down here, x plus 8 times x plus 3. I'm going to do that again with the center, which is what numbers multiply to 16 and add to 10. Okay, and those numbers would be 8 and 2. So this is x plus 8 times x plus 2. And the last one, what two numbers multiply to 6 and add to 5? Those numbers would be 3 and 2. So this is x plus 3, x plus 2. Okay, so there's a lot going on here. So I'm going to use some colors to help us out. So I have an x plus 8 in these two, but not the last one. So that means I need to add an x plus 8 to the center. To the last one, okay? Now this one has x plus 3 and so does this one, but the middle one does not. That means I need to add x plus 3 to this one, okay? Now the middle one has x plus 2 and so does the last one, but the first one did not. So this one, I need to add x plus 2, okay? At the end, make sure that they all have the same 3 factors, which they do now, okay? So now we'll focus on setting all of the numerators equal to each other. So we have 2x squared times x plus 2 plus 3x times x plus 3 is equal to 2x times x plus 8. We're going to distribute to get 2x cubed plus 4x squared plus 3x squared plus 9x equals 2x squared plus 16x. Okay, let's combine our like terms. We have 2x cubed plus 7x squared plus 9x. And I'm going to want to move everything to the side that has the variable with the largest exponent, which is x cubed, and on this side it is positive, and you don't want to move everything here because then your largest exponent coefficient would end up being negative, and you don't want that. So instead, I'm going to subtract this to this side. So I'm going to do minus 2x squared minus 16x to cancel this out. So now we have 2x cubed plus 5x squared, and then 9 minus 16 is negative 7x. Okay. Now you cannot use x method for polynomial that is cubed, but because they all have at least one x, I can use the greatest common factor and take out an x from all of them. Okay, so I can divide all of these terms by x. And so if I divide by x, I would have left 2x squared plus 5x minus 7 equals 0. Now that the inside of the parentheses is a quadratic, we can use x method. Remember that at the top you have a times c, so 2 times negative 7 is negative 14, b is 5, and on the sides we have 2x. So what two numbers multiply to negative 14 and add to 5? Negative 2 and 7. Negative 2 divided by 2 reduces to negative 1 over x. So now we have x times x minus 1 times 2x plus 7 equals 0. Now we can separate all of these into 3 separate cases to solve for x. X equals 0 is done. Over here we're going to add 1 to get that x equals 1. And then here we'll subtract 7 and then divide by 2 to get that x equals negative 7 over 2. But don't forget that you always have to check the vertical asymptotes to make sure that there's no extraneous solutions. So the common denominator was x plus 2 times x plus 8 times x plus 3 equals 0. So we're going to separate these and set them equal to 0. I'm going to subtract 2. X cannot equal negative 2. On this side, we're going to subtract 8. X cannot equal negative 8. And when you subtract 3, you get that x cannot equal negative 3. So you have vertical asymptotes at those 3x values. These x values that we got as solutions are not affected by the vertical asymptotes, so all 3 of them are solutions. Just make sure that you write them in order from least to greatest. Okay, so let's go ahead and try another one. What values of x make this equation true? We're going to start the same process where we're going to factor and try to get a common denominator. Okay. Now this one, I see that we have 4 and 25, and I'm recognizing this as the difference of perfect squares, where I can do plus or minus. So the square root of 4 is 2, the square root of x squared is x, and the square root of 25 is 5. And then remember that for difference of squares, it's the same factor on the other side, but with a minus. That's the plus or minus side of it. Okay. Now this side already has 2x minus 5, and this side has 2x plus 5. So that means I'm going to need to add the 2x plus 5 here. And on this side, I need to add 2x minus 5. And now we can worry about the numerators. So 3x squared plus 4 minus 2 times 2x plus 5 equals x times 2x minus 5. I need to distribute this negative 2, and it's important you don't forget the negative because that'll affect the entire answer. And then we're going to distribute this x. So 3x squared plus 4 minus 4x minus 10 equals 2x squared minus 5x. I want to combine my like terms, so 3x squared minus 4x minus 6 equals 2x squared minus 5x. I'm going to move everything to the left side because on the left the coefficient of x squared was larger, and I want to make sure that the x squared stays positive. So 3 minus 2x squared is 1x squared plus x minus 6 equals 0. I can factor this using x method. So the numbers that multiply to negative 6 and add to 1 would be 3 minus 2. So this is x plus 3 times x minus 2 equals 0. And then I can split these up and solve for x separately by subtracting 3 and adding 2. So x equals negative 3 and x equals positive 2. But don't forget to check for your vertical asymptotes because these could be extraneous solutions. So we have 2x plus 5 times 2x minus 5 equals 0. Okay, I'm going to set this one to 0. I'm going to subtract 5 to get 2x equals negative 5. Divide by 2, x cannot equal negative 5 over 2. And on this side, we're going to add 5 to get 2x equals positive 5 divided by 2. X cannot equal positive 5 over 2. So our solutions are okay. In order from least to greatest would be negative 3, 2. Okay, let's go to the next one. Subtract 3 divided by x minus 1 minus 2 divided by x. I'm going to start by putting all of this in parentheses. I cannot factor x minus 1 and I cannot factor x. So the only thing I can do is go and add these on either side. Now that I have a common denominator, which is x times x minus 1, I can merge all of my numerators together, which would be 3 times x minus 2 times x minus 1 all over the common denominator of x times x minus 1. Okay, we're going to distribute which would give us 3x minus 2x plus 2 all over the common denominator of x times x minus 1. And now I'm going to combine my like terms, which would be x plus 2 divided by x times x minus 1. Now nothing cancels out, so this would be the final answer. So the answer choice that matches would be C as in cat, x plus 2 divided by x times x minus 1. Okay, let's go to question 20. So this one is similar. I'm going to wrap everything in parentheses. I cannot factor n minus 1 or n plus 3. So I'm going to multiply either side by the factors that are missing. Now we're going to rewrite the numerator. Remember that you always want to put your single numbers and single letters, the variables in the front. So we're going to do 8 times n plus 3 minus 4n n minus 1 divided by the common denominator n plus 3 times n minus 1. We're going to distribute the 8 and we're going to distribute negative 4n. So we would get 8n plus 24 minus 4n squared plus 4n all over n plus 3 times n minus 1. This becomes negative 4n squared, 8n plus 4n, 12n plus 24 all over n plus 3 times n minus 1. Okay, now normally I would have you guys take out the greatest common factor and then factor using X method, but I am seeing that the answer is left in this format, a little bit out of order, but essentially the same thing. However, technically the greatest common factor would be negative 4, and you can factor them all by negative 4, simplify, and then do X method to simplify it further. Okay, but we'll leave it like this because that's the answer choice already. All right, here's question 21. We're multiplying the first two fractions and dividing the last one. So remember, with division, you do keep, change, flip. So before you even start factoring, I want you to do the flip part. Okay, so I'm going to rewrite this. Which is not going to fit here. So I guess I'll put it, I don't even know. Maybe I'll just make it smaller. Okay. Times, I'm going to flip this one around. So you find the division sign and the one after that is the one you flip. So you don't flip everything, just the one after the division sign. Okay. After this, you're able to start factoring. So we're going to do X method. So what multiplies to 3 and adds to 4? That would be 1 and 3. So in the numerator, we now have x plus 1 times x plus 3. Okay, let me color code this so hopefully you don't get lost. The next thing we're going to do is the 2x squared minus 7x minus 4. So 8 times c is negative 8, negative 7, 2x on the sides. So for this one, we have negative 8 and 1, and this reduces to negative 4. So in the denominator, we have x minus 4 times 2x plus 1. Okay, now we'll move on to the middle. I'm running out of space. I'm going to do that one over here. We have numbers that multiply to 4 and add to -5. That would be -1 and -4. Okay, next we have two numbers that multiply to 6 and add to 5. That would be 3 and 2. Okay, and then we have the next one here. I can do the difference of perfect squares because 4 is a perfect square and so is 1, and I can just put a plus or minus on that. So the square root of 4 is 2, and then the square root of 1 is 1, so this becomes 2x plus 1 times 2x minus 1. And then in the bottom is another perfect square, so this will be x plus 1 times x minus 1. Okay, so this is everything in factored form. Now let's start identifying what can be canceled out. X plus 1 cancels with this one, x plus 3, x minus 1, x minus 4, 2x plus 1. Okay, so if you see what is left over, we just have 2x minus 1 in the numerator and x plus 2 in the denominator. Remember that your vertical asymptote comes from the denominator set equal to 0, and when you subtract 2, you get that x cannot equal -2. So the correct answer would be C as in cat for number 21. Okay, let's go on to the next one. Which expression is equivalent? I have two different denominators that cannot be factored. I like to start by putting everything in parentheses. To get a common denominator, I'm going to put those denominators on the opposite fraction, so that now the two denominators have the same two factors of x plus 2 times x minus 1. Okay, so now I'm going to bring this all together. X minus 1 times x plus 3 plus x plus 5 times x plus 2 over the common denominator of x minus 1 times x plus 2. The only way to multiply these is to do box method. So I'm going to do box method with x minus 1 times x plus 3. Okay, so that gives me x squared plus 2x minus 3. Now I need to do another box method because I have two factors over here. So we're going to do x plus 5 times x plus 2, x squared, 5x, 2x, and 10. So plus x squared plus 7x plus 10 all over the common denominator, x minus 1, x plus 2. Let's combine the like terms. I see 2x squared, so that'll be 2x squared plus 9x plus 7. Let's make sure x squared plus x squared is 2, 2x, 9x, and then -3 plus 10. Okay, divided by x minus 1, x plus 2. Now let's factor this using x method. So 8 times c would be 2 times 7, which is 14, and 9. Okay, we can do 7 times 2 is 14, and when you add them, it's 9. So, and then this is 2 down here, so this reduces to 1 over x. So this would be 2x plus 7 times x plus 1 over x minus 1 times x plus 2. And let's try to match the answer. Looks like it is answer choice A. Okay, where is there a hole on the graph? So remember that a whole happens when common factors from the numerator and the denominator cancel out. So first you need to factor. I can factor this numerator using the difference of perfect squares. So we have x plus 2 minus x minus 2. And for the denominator, I can use x method. So what numbers multiply to negative 10 and add to negative 3? That would be negative 5 plus 2. So we have x minus 5, x plus 2. These cancel out, and that automatically creates a whole at x plus 2, and to find it, you set it equal to 0. Now I'm going to keep going and write the simplified equation because this is the one we're going to use to find the y-coordinate of the whole. Okay, so let's keep going over here. I'm going to subtract 2. We have a whole at x equals negative 2. To find the y-coordinate, you're going to use this one, and you're going to plug x into negative 2 into x. So it'll be negative 2 minus 2 over negative 2 minus 5. And you can put that in the calculator. So like struggling to split the screen. Negative 2 minus 2 divided by negative 2 minus 5 is equal to positive 4 over 7. Okay, so the correct answer would be B as in boy. Find the coordinates of the whole. Okay, so we're going to repeat the steps. We need to factor. You could use x method here, but I would recommend that you divide both of these by x because you can also use the greatest common factor. So we would have x times x plus 3 divided by x plus 3. A whole occurs when the same factors cancel on the numerator and the denominator. So our simplified equation would be what's left over, which is x divided by 1. So for the whole, we're going to rewrite whatever we canceled out and set it equal to 0, and then solve for x by subtracting 3. And to find the y, remember that you plug it into the simplified, so that would be negative 3 over 1, which is just negative 3. So the correct answer is A as in apple. Okay. Moving on to the next one, what is the horizontal asymptote? So remember for this one, you analyze the exponents. So this one has an exponent of 1 and this one has an exponent of 2. It's bigger on the bottom. Bigger on the bottom is Bobo, and this stands for y equals 0. Okay. You also have bottom, which is bigger on top, none, and etc, which is exponents are the same. Divide the coefficients. Okay, but every horizontal asymptote, you look at the exponents. Okay, here's another one. Let's try to figure out the horizontal asymptote. So the largest exponent on the numerator is 2, and on the denominator it's 1. So this is for the horizontal asymptote, bigger on top, none. So there is no horizontal asymptote. So this answer choice that says the HA is at y equals 0 would be incorrect. Okay, now we can factor the numerator to figure out what multiplies to 10. That would be 5 and 2. So we would have x plus 5 times x plus 2 divided by x plus 5. This cancels out, which already creates a whole. I'm going to copy this so I don't forget. And then I'm going to go back and write the simplified equation because that's what I need to use for my x-intercepts, my wholes, and the vertical asymptote. Okay, so back to the whole, I'm going to subtract 5. We have a whole at negative 5. For the y-coordinate, we're going to plug it back in here. So negative 5 plus 2 over 1, that would give us negative 3. Okay, the whole is at negative 5, negative 3, so A would be correct. Now let's see what the vertical asymptote is. The vertical asymptote comes from the bottom, and 1 does not equal 0. So there is no vertical asymptote. Okay? So the domain skips, since there's no vertical asymptote, it'll only skip the x of the whole. And the range is only going to skip the y of the whole. Now, that's because there's no HA and no VA. Normally, the vertical asymptote is also skipped in the domain, and the horizontal asymptote is also skipped in the range, but we're not worried about that for this particular problem, okay? So the domain is all real numbers except the x-coordinate of the whole, which is here. So B would be correct. And then the y-coordinate of the whole is skipped right here, all real numbers except -3, so D is also correct. So 26 has A, B, and D as the correct answers. Okay. What is the domain of x squared minus 4 divided by x squared minus 3x minus 10? Okay. So I'm going to factor this using the difference of squares. So we have x plus 2, x minus 2 divided by, we did this one earlier. Let me see where it is. Minus 3x minus 10. It's right here. X minus 5, x plus 2. And we had canceled these out, leaving us with x minus 2, x minus 5 as the simplified equation. We have a whole at x plus 2 equals 0, which has the whole at x equals -2. And then we have a vertical asymptote at x minus 5 equals 0, which we can add 5. And there's a VA at x equals +5. So for the domain, you're going to skip the VA and the x of the whole. That's all you have to worry about for a domain. And then if it's the range, you do the HA and the y of the whole. Okay, that's important to remember. So I'm looking for an answer that skips -2 and 5. So that would be C as in cat. Okay. Number 28. So this is the same exact problem. So I'm just going to carry on with the work that we had here. So we're going to find now the range, which skips the horizontal asymptote and the y value of the whole. So let's find the horizontal asymptote. Let me analyze my exponents. Largest is 2 in the top, 2 in the bottom. Exponents are the same. So that's each DC. Exponents are the same. I need to divide the coefficients. The coefficients are the numbers in front of the variable. So that's 1 divided by 1, which is 1. Okay. Now I also need to find the y value of the whole by plugging in this x value of -2 into this equation. So that'll be -2 minus 2 over -2 minus 5, which was -4 over -7, which simplifies to 4 over 7. So we need an answer that skips both of these numbers, which would be letter D as in dog. Okay. Number 29, what affects the domain of a function? I already told you that earlier. The domain is affected by the VA and the x value of the whole. That's it. So the vertical asymptote, the x value of the whole, the x-intercept has nothing to do with it, and neither does the HA or the y value. And then for the range, it's the opposite. It's the horizontal asymptote and the y value of the whole. So not the VA, not the x, not the x-intercept, but the horizontal and the y value of the whole. Okay, I hope this was helpful. Let me know in class if you have any questions before the test, and study a lot. Thank you for watching. Bye.